Fractal geometry, developed by Benoit Mandelbrot in the 1970s, is the magical connection that brings together math, art, and nature. Imagine that you had an equilateral triangle, then imagine splitting that triangle into even smaller triangles. Repeat this process indefinitely, and you're left with what is called a Sierpinski triangle. Now here's a question. What dimension is it? If the triangle were one-dimensional, its length would be infinite, since there are an infinite amount of lines within infinitely repeating triangles. If the triangle were two-dimensional, its area would be infinitesimal, since the total area would shrink with every division. It's too big to be one-dimensional, but too small to be two-dimensional, so it must be in between. This is where Mandelbrot derived the term fractal, describing a figure with a fractured dimension. But to be a true fractal, its fractal dimension must go on forever. The fractal dimension of the Sierpinski triangle is irrational. Because it goes on forever, this triangle is a true fractal. Here's the British coastline. Like the Sierpinski triangle, it has repeating patterns and branches, but its fractal dimension is finite, so it is not a true fractal. The fissures we see in soil split into repeating branches that expand out, split further, and so on. These patterns are similar to the veins on leaves, which also have fractal properties. Fractals are used to model the layout of cities, to design treatments for cancer, and are used to create the graphics you see in movies and games. Fractals have infinite complexity and inspire infinite creativity. As Mandelbrot once said, fractals help all of us see the world differently.